Okay, all right. Happy Monday, everybody. It is, we are talking about lists today. I think this has been published, right? Let me just check. GitHub, Smiles Chen. Yep, 3-1, lists and strings. Okay, yeah. And is everybody's Git pull upstream main, that's all working for everybody? We got that all set up? Okay. If you're having issues, come see me in office hours. We'll get you squared away. Um, it looks like most of you got your homework turned in and everything, so that's good. But again, yeah, the key is it needs to be a PDF in Pages when you submit. Okay, and I think most of you did that, right? So, but if you submitted like one giant long HTML thing, like, well, you'll get your grade feedback, and then you'll probably have to resubmit. But anyway, okay. We're gonna keep talking lists here, okay? So I think we started talking about lists, but I want to just kind of re-emphasize and go over some of this stuff again. So in Python, lists are one of the kind of most versatile data structures that we have. We use them a lot, like, I guess, in R you have lists and you have vectors, and they're kind of like that, but also, you know, a few things that are different. So one thing, lists are mutable in that you have a list object, and you could call methods on that list object, and it will change the actual list object. And so, and if you use names in such a way, like you could create a second name, and it will point to the same list object. So here in this code, I created a list object called fam. I created another name called second, but this second thing is pointing to the exact same object as fam. Okay, so you just have to kind of think, you know, here's this list, this box of stuff. Okay, and you know, first I put kind of a label, and it says fam on it. Okay, and then I put another label, second, on it. And so both of those names point to the exact same thing. And so here I changed one of the objects in that list. I said, hey, index 0, change it from Liz to sister. Okay, and then now I say, hey, print out what this thing is. Okay, second reflects that and says, hey, that first item, index 0, is now sister. But then I say, hey, print fam, and because it's the exact same object, it shows us the exact same thing, that sister is 0. And this is different from R. R has copy on modify semantics. So like when you change something, it actually creates a copy of it and stuff like that. That Python doesn't do that. Okay, if you do want to deal with a copy where changing one thing doesn't affect the original thing, you have to tell Python, I want to make a copy, right? So here I've got fam. I can print out fam. Here, second is equal to fam, and I'm using square bracket, colon, square bracket. So this is, I'm using the slice technique, and using a colon will slice things, but here I didn't specify a beginning or an end, so it's just going to slice the whole thing, right? From the very beginning to the very end. And then so now second is now a copy of fam. And then I say, all right, change index 0 to sister, and then I say, hey, print out what second is. So that's going to show that sister has changed, but the original fam object is unaffected by that operation. Okay, so this is one way to create a copy. Another way to create a copy is just to do fam.copy. So the list object has a method called .copy, and we'll call that thing third. That's our third object. Here we're going to change the index 1 to 1.65 instead of 1.73, and that's reflected here. Okay, and in all of these things, fam is unaffected. Fam remains as it originally was because we were making changes to the copies on all of these things. Okay, there's you can also take something and call list, and list, you put something inside list, it'll generally create a try to create a list out of that thing or put it into a list. Here, fam itself is a list, so when you call list on the fam, it creates another list. And this again is like a copy. Okay, creates a new list object that contains all of the elements of fam. So this is a copy. So all of these things create copies, whereas this very first box up here where I said second equals fam, this just references the same thing there. It's just a second name for the same object. But all of these other things, all of these other boxes, all create copies. And then right here is you can also use assignment in conjunction with slicing. And so when I say fam 1:3, that references the values between the first and third commas, which right now is 1.73 in Emma, but I could change those values to 1.8 in Jenny, and so so that's what we end up getting. Okay. All right, these are methods that exist. We've already seen list.copy, but list.append will just take the existing list and add items to it. So notice though how one thing you have to kind of be careful of is that after you run fam.append, if I just comment out this print line, okay, it doesn't, like, Python doesn't give you like feedback. All right, you just said, hey, fam.append, and it runs it, and Python doesn't report anything back. It just says, okay. it just runs it. It doesn't return an error or anything. But then when you ask, hey, what does fam look like? It indeed appended it. Okay, and so if you if I kept running this like fam.append me again, if so, like, oh, I was like, oh, did something happen? And I run this again, you know, yeah, it keeps tacking them on. Okay, it keeps tacking them on. Now in this code chunk, I start the code chunk off by defining fam from the very start. So here, if I run this, this will appear once, and then if I run this again, I'm not going to get me twice there. Why not? Because I'm just creating fam all over again at the very beginning of the code chunk. Okay, so anyway, just be aware that when you run something like .append, you're not going to get immediate feedback. It'll just run it, and you just have to kind of trust that Python did what you asked it to do. Okay, and it does. It does. You don't have to worry about it. But if you're always kind of in this expectation that I do something and it does it back and tells me like back and forth, you don't get that kind of response. Okay. Here, you can also take an existing list and you can add another list to it. Okay, the plus here takes one list item or one list object and takes another list object and then just concatenates them together. So here I'm just concatenating 1.8 to fam here. Okay, and then I'm saving this. I'm saving this back to fam. Okay, and so when I do that, now I get 1.8 appended to the end of the thing here. Okay, if I run this again, what's going to happen? I'm going to get 1.8 tacked on again. And every time I run this, it keeps adding another 1.8, because here I'm saying take this, add 1.8, and save it back to fam. Take this, add 1.8, and save it back to fam. Okay, so I don't really want that, so I'm going to go back to this thing where I redefine fam at the start. Okay, and then I'll do this. All right, we've seen fam.append. Again, here I just run this. Python doesn't tell me anything. It just says, the only indication that it ran is that in IPython it changes from this indicates like it hasn't been run, and then now you get a number here to indicate like this is the 21st command that I executed. Okay, now I can say, hey, did this happen? It did. Okay. Here I do fam.append. If you give it like a list with a whole bunch of things, it's going to append this as an entire object. Right? So when you look at it here, and actually it's not going to fit on the screen, so this is just I guess output formatting, okay? It's the exact same thing, it's just because it couldn't fit it all sideways, it starts to list them off vertically, that's all, okay? And then you can see, now I have a list inside the list at the very end there, okay? All right, I'm gonna reset, I'm gonna just redefine FAM as a list here, and then I can just do the plus here, and this will kind of combine everything into one long list. Here, because I didn't save FAM anywhere, I just did FAM plus this, FAM is still just the original list as I've defined it, okay? You can also do stuff like FAM times 2 or FAM times 3, and it just kind of takes the list and it multiplies it, concatenates it, makes it longer. All right, let me give you your first VQuiz answer, which is the letter A. A as in apple. A. We have something known as a deep copy, and we have shallow copies and stuff. And so this is going to try to illustrate the difference between them. So remember, lists can contain other objects, like a list can contain another list. A list can contain a function. A list can contain. A list can also just contain the name of another object. Okay. So you can also just contain the name of another object, or I guess a reference to that object. So here, I'm going to create a list called A. A consists of A and 1, 2. I'll create a list called B, and that contains B, 3, and 4. And C is a list of lists. C contains A and B. It's a list containing list A and containing list B. So this is what it looks like. So okay, here, this is what A looks like, this is what B looks like, and this is what C looks like. C is a list of lists. Okay. So far so good. I'm going to create a copy of C, and I'm also going to create a deep copy of C. Okay, so deep copy is in the copy module, so you have to import copy, and then you do copy.deep copy. Okay, so D is going to be a shallow copy of C. This is done just by doing slice it with everything, or you can just do c.copy. That will create a shallow copy. E is a deep copy. So right now, D and E look exactly the same. Right now, D and E look like they look exactly the same. All right, let me just show you what happens here, okay? I can append X, the letter X to C, okay? When I do this, I've appended the letter X to C, and D is a copy, shallow copy of C, so it is unaffected when I changed C, and E is a deep copy, so it is also unaffected, right? So here I have C, okay? And then right now it contains A, 1, 2, and B, 3, 4, all right? I don't know if you can, I don't know how to point my camera here. All right, and then I created a copy D, so this will have A, 1, 2, and B, 3, 4, okay? But this is, I guess, I have A, which is A, 1, 2, and B, which is B, 3, 4, okay? So this is shallow. All right, and then I got B, which is A, 1, 2, and B, 3, 4. All right, and this one is deep. All right, what is this? Okay. So, so here I just said, hey, you know what? Let's copy. Let's modify C. Let's append X to it. Okay. Now these were copies, so unaffected. Unaffected. All right. This what I'm going to do now is I'm going to append the letter Z to A. Okay, so when I do this, this contains a reference, so this will also get the Z. And the shallow copy contains a reference to A, so it also gets modified. But this one is a deep copy, so so this is an entire new object. So I mean, I don't know, how do I show that these are like, this references this thing? Okay, I'm gonna put little stars here. Okay, so these reference the same object there. Okay, this is also references B, but these are copies over here. So if I append Z into A, all right, and I say, hey, what does C look like? C is going to have A12Z, B34, and X. Okay. What does D look like? D is going to have A12Z and B34. And what does E look like? E is a deep copy. So this thing that has A12 is not affected by any changes I make to A there. So that's the deep copy. All right, so that's what we have. Okay, and then A has been modified because we appended that. We have a few more methods. We got list.insert. This inserts an item at a given position. The first argument's the index of the element before which to insert. So A.insert 0 inserts at the front of the list. A.insert at the length of A is equivalent to append, basically. All right, so here I've got Liz 1.73, whatever, the fam, and then I'm going to say insert at 4, Joe. So you can think of this as inserting at the 4th comma. 1, 2, 3, 4. So index 4 is mom. It's going to go right before that. So Joe becomes now the index 4 object. And we do that. And so now we get Joe and then in front of mom. If you try to insert, say, a list with Joe and 2.0 here, then it's going to insert that list entirely as a list. Okay, so here I'm redefining the fam list. Okay, so we're not dealing with the one up here, but we're doing a new list entirely. And I'm going to insert Joe 2.0 right here. Okay, but here now I have a list contained inside of there. All right, if you try to insert more than one thing, Python complains. Okay, it errors out and says, hey, you can't do that. What can you do, right? Well, one is you can do extend. Extend will allow you to put in an iterable and it will add them at the end, but it goes at the end. If you wanted to insert two things at one location, like if you wanted to put Joe 2.0 in line with everything else, you can use assignment in conjunction with list slicing. So I'm going to slice it down to 4:4, which is really just kind of like the comma position there. And then I can say assign Joe and 2.0 there. And so this will insert those values right there. Okay. So I think you had a homework problem where you had to do that, and I don't know what solution you guys came up with, but this was one simple way to take it, right? There's hundreds of ways to have addressed it, and I am curious to see what you guys did, but maybe it was this, or maybe it was something different. I don't know. You run a for loop for every single item. I don't know. Could work. Maybe not the most efficient. Okay, we got remove. Simple, just takes things out of the list. So no surprise there. Gone, okay? And when you remove it, it's just gone. It's not like, that's it. Okay. If you have multiple matches, so here I've got 1.71 Emma, 1.68 mom, and 1.71, it's just gonna remove the first match. So it reads it left to right, and then it says, here's a 1.71, I'm gonna remove that, okay? So it doesn't do a comprehensive search. It's not gonna search over the entire list and remove every single element. instance of it. It just removes one of those things. Okay. Here, wait. Let me just. Okay. So here, fam looks like this. If you do fam.remove something that doesn't exist, okay, you get an error. Right. So that's not an example that I put in. But if you try to remove something that doesn't already exist in the list, you give you back an error. X is not in the list. Okay. If you do pop, okay, it's going to pop the last item in the list, and that item that it pops can be captured here. So I can do fam. I redefine the list here. I'm going to do fam.pop, okay, and it's going to remove the last item, but that last item is going to get stored in as J. So I can ask, hey, what did you just pop? 1.89, and so the list is now shorter without that last value, and you've removed it. Okay. You can also provide an index, so you can do something like pop 0, and that will remove the first index 0 item. Okay, and it will give you everything back. Okay, so you can capture that. So you can just also remove a certain value at a certain index and capture it as well. And then fam.clear will just wipe out the entire list. You might wonder, like, why would I have to do that? Why don't I just define a new list? Okay, well, sometimes, so there's a difference. So if I have a equal to this, all right, I could create a new thing, all right, like this, and the name a will reference this, but these things that have like, remember, C contained a reference to this list. It still references this list. It's just the name, we no longer have a name for this thing, okay? So we can still kind of, I could say, hey, what was the index 0 object in C? And I want to like modify that, and I can do that. And that will affect the shallow copy here. So like, here, let me, now I want to show you. Okay, so here's A, and here is C, and here is, what was the other thing? Okay, D, okay? So here I can do like A is equal to now this. And so A looks like that, and C looks like this. But I can do something like C, give me the 0 index object, and I can say, here I want to do dot append X, okay? So if I do that, C now looks like this. And remember, D contains a shallow copy of C, so D, that object is there. But A is still this empty thing. If I wanted to actually clear this thing out, okay, the reference, these things, I can't, doing A equals this no longer works. I think I can do this, right, to kind of get back what I have here. So now I have this, and I can do A.clear. So A is now empty. And now if I ask what is C, now it's been cleared, and D is cleared. E, remember, was the deep copy of all of this, so this still has the whole thing. Okay? So you can't just do A equals 0 and expect that to have, this is redefining. This is defining an entirely new list, and we're using the name A to reference this thing. This thing up here that we created earlier still exists, and it's just like we lost a way to reference this thing by name. Like, we took away its name, and we're like, oh, how do I get this thing? Well, luckily I still had, like, it existed inside of C, and so I could reference that thing. But you can't just like say, hey, here's an empty list, and I'm going to call this A. Does that kind of make sense? The difference between just doing this versus A.clear? Okay. Well, anyway, that's that. Okay. List.index. Okay. So list.index will return basically the index of the list where the first value matches whatever x is, okay? And if that doesn't exist, then you get a value error. So here I'm defining all of these things. Every time you see this equals, I'm defining an entirely new list, okay? And this is just kind of resets everything and stuff. And some of these things, like the old list, still kind of exist in memory, but anyway, redefining an entirely new list. I'm going to say, hey, what is the index of Emma in this thing? And it's going to say, okay, 0, 1, 2. Emma is number 2, okay? If you do fam.index3, okay, it's not going to tell you like, oh, the third thing, index 3 position was 1.68. It's just going to say, you're asking, hey, what is the index of the value 3? And Python's going to say, what? There's no 3 in the list. There's no index there, right? What do you do if you wanted to get the thing in position 3? Square bracket, right? Fam square bracket 3. All right, so here I've got letters A, B, C, A, A. Okay, and I can say dot count. Count will just tell you how many times that that value appears. Okay, and it says, oh yeah, that appears 3 times. Again, here, let me just do letters dot index, index A, and here this just gives you it's an index 0, index position 0, index position 0. Just the first encounter. Python, again, inherently lazy, and that's not a bad thing, right? And if you say say a human is inherently lazy, then that's like an insult. But this Python is just like, it's gonna do it, and it's gonna give kind of, most of these functions are defined to kind of like give you once it encounters the first thing, it's going to stop evaluating to kind of save computational calculation times. Okay, so here fam is a list of lists, and so if you say something like, hey, where is Emma by itself, that doesn't exist inside the thing, so you get a count of 0. Fam.count of, does this actual item exist, then it does that. Okay, you got sort. List.sort will sort it in place. Again, it just kind of modifies that object in memory in place. So so here's the object right now, fam. I can do dot reverse, and this changes it in place, and it does that. Dot sort, here it's going to complain because I've got a mix of strings and floats, and it says I don't know how to sort. I don't know how to sort strings and floats. Okay, but here I've got some numbers here. These are all numeric, and you can see I've got a mix of integers and floats, and it has no problem. It has no problem sorting that. Okay, so here it sorts them from least to greatest, and it preserves the types. These are still integers. This is still a float. No problem there. Okay, you can say, hey, what's that position 4? Position 4 is a float. Okay, you can also do it in reverse order. No problem. Okay, here I've created an entirely new list called sum digits, and I can do sorted. So this, and I think I showed an example of this earlier. But dot sort is a method that exists for a list, and it modifies the list in place. And again, anytime you do something like this, like some of these methods, you don't get immediate feedback that says, "Yep, I did it." Okay, and you have to kind of ask, like, "Did you do it?" And you say print the list, but you're not going to get the feedback every single time. Here, I want to start working with strings. Let me give you your second view quiz answer. The letter E. E as in elephant. E is our second view quiz answer. Strings. Strings are a sequence. So it's you can almost think of these as like lists in that, like, but every character is something in this sequence here. Okay, so here I've got bananas, and you can just say, hey, what's at index position 0? The letter B. What's at index position 1? The letter A. What's at index position -1? It's the last letter, S. Okay. If you ask, hey, what's at index position 1.5? It says, hey, you can't do that, right? I'm not going to tell you what's there. Len tells you the length of a string. Oh, I guess I forgot to write this, but len will also tell you the length of a list. So here's some digits, and len on this, there's 7, okay? And len on a string, or any iterable really, so tuples, dictionaries, they'll tell you how many things are in there, okay? So it's one of those universal things. You can subset strings just like you would subset a list, okay? So you just have to imagine, so a list has commas. Strings, obviously, I mean, you can have a string with commas, but you don't have any kind of like separator character in between each of these things. But you just imagine, right? So S4:9, where is that going to go from to where? From where to where, right? If I've got A through Z, A, B, C, D, E, F, G, all right? So counting A, B, C, D. So we're going to go in between D and E. We're going to start there. E is 4, F, G, H. I can't count. Okay, 4, 5, 6, 7, 8, 9. I think we're going to go from E to I. Oh, I didn't define S. Okay. There we go. Okay. E, F, G, H, I. All right, okay, I can still count. All right, -6, : where is that going to give me? The last 6 letters of the alphabet. We all know X, Y, Z, but then if you say, hey, what's the last 6 letters of the alphabet? That's like, now I got to start at A and go, okay, and that's going to be U, V, W, X, Y, Z. Okay. And then, and you can kind of iterate over a string as well. So you can say like for X in S, 0:5. So that's going to be the first 5 letters. And we can just print X and an exclamation point. And we're going to, it's like, talking to a toddler who's excited about learning the alphabet. Okay, so we got, A, B, C, D, and E. Strings, however, are immutable. Okay, so with lists, you could do something like change the object in position 0, from, what was it, Liz to sister or something like that, okay? You can't do that with a string. So here, string S is A through Z. And if you say, hey, I want to change index position 0 to the letter B, Python says, nope, you cannot do that. String object doesn't support item assignment, okay? So if you wanted to do something like take the letter B and everything else, then you would just have to manually create a new string. So you do something like B plus this thing. So this is just creating an entirely new string. We're not modifying the string. So that's one thing to know, okay? Strings are immutable. Other objects that we'll cover, like tuples, also immutable, and you're not allowed to do assignment, okay? So there's no, you can't do a string.append, okay? String.append would like add things to the string in place. There's no string.sort because it sorts the string in place. So that there's none of that, okay? But here you can do, there are methods that take the string and just kind of give you back, I guess, versions of the string. None of these modify the string itself. So here I got name, stats 21, Python and other technologies for data science. I think that's the official name of this class. Okay, .upper will turn everything into uppercase. .capitalize capitalizes the first letter of each after a space. Here. No, I'm sorry. .capitalize just capitalizes the first character of the entire string. Everything else is lowercase. .title does the first character after a space. Now this doesn't follow, it doesn't know what the standard practice is for writing like titles in English, which is you don't capitalize conjunctions and prepositions or something like that. I don't know, what's the rule for, are those articles, conjunctions, and prepositions don't get capitalized? I think that's how it works. So normally you wouldn't capitalize and, you wouldn't capitalize for, but whatever. It doesn't know that, okay? It doesn't know. So it just it says, there's a space, we're going to capitalize the word after that, okay? Lowercase makes everything lowercase. Again, none of these modify any of the original strings, so the original string is unmodified. Okay, you can go through and you can create a little loop to say, well, how many times does the letter E appear in the string, okay? And so, so here I wrote this little loop that says for every letter in this name, let me get rid of this, iterate through it, and if the letter is equal to E, add 1 to the count, okay? I could have just also done plus equals 1. And it goes through and it gives me a 5, right? We have nice little things. Dot count does the exact same thing. So that's a handy little shortcut method. Dot index, just like a list, okay? With a list, it'll tell you what's the index of the first encounter of this. You get that. And again, just like a list, if you give it something that doesn't exist, okay, it's going to say, hey, I couldn't find that. You don't have to just do single characters. You can give it something like this, and let's see, I think that it detects the THE in other, something like that, okay? Space, that's going to say it doesn't find it. So you can give it, so dot index, you can give it entire like words and stuff. But again, this is it's just looking for a string sequence, THE, not necessarily the word the. I don't think this support. Ooh, now I'm curious. Yeah. Okay. Wait. Well, I don't know. Yeah. Okay. So you can't do. Yeah, you can't. It doesn't support regular expressions off the bat. You can do regular expressions in Python, but you got to load the RE module. So, okay. You have Boolean expressions, things like, does the string end with a K? Does it end with an E? Does it start with an S? Okay. Yes, no, or I guess false, true. You can create multi-line strings with triple quotes. So triple quotes to open and triple quotes to end. And when you print it out, it looks like that. Dot strip removes extra white space, returns something without the extra white space. But again, names themselves are immutable. So if you ask, hey, what is the thing? It just tells you like, oh yeah, I got all these new line characters. More methods. String split takes the string, takes a character, splits it on spaces, or splits it on any character you specify. So here, remember, name is, I don't know, the name of the class or whatever. Or no, here it was Miles Chen, I guess. So if you split it, it looks at the spaces and splits it between my first and last name. Here is a string with numbers and commas, digits and commas, I guess. When you do dot split, it doesn't see any spaces, so it just gives me back a list with one thing in it. If I say, hey, split on the commas, gives me back a list with the different digit characters. Now, this here is a list of characters, the character 2, the character 3, or the string 3, the string 4. They are not things, so you can't add them. But you can do like a list comprehension and turn them all into integers. I will cover list comprehensions later, but just for now, you can kind of do for x in numeric string dot split. So the result of this numeric string dot split is this list, and you can say for x in that, make integer x. Okay, so this is like integer x. Just turn all of these things into integers, and now you get a list of the integers. This list comprehension is basically a more concise version of this, where I just start off with an empty list, and then I say for each element in numeric string.split, do l.append the integer x. So if you're not comfortable with the list comprehension, you can just write a little for loop to do the exact same thing. We have a few more Boolean expressions. So you have is alpha to decide if something is alpha has alphabet characters only. So because there is a number 21 and there's spaces in it, is alpha is going to return false. Okay. However, if you have something like ABBAAZ, so lowercase or capital letters, if it consists only of that, is alpha will be true. If it has a single digit though, is alpha will return false. Okay. And there's more of these things. There's is alpha. There's is alpha numeric. What are the other sister functions of this? String methods. Okay. So you have is alpha, is alnum, is ASCII, is decimal, is whatever. You got a whole bunch of these. And they all return true false things, which is good for, like, I don't know, form entry validation. You want to make sure someone's not going to try to inject some kind of bad code, malicious code into your thing. Gotta clean up your stuff. Okay, you can also, so we have a multiple line thing. You can turn the whole thing into uppercase. You can split it at the spaces, okay? And you can do this, and you can kind of start taking these words and sorting them and start doing some basic text analysis. If you got multiple lines, you can also split on the lines, and this will split at line ends. And that works fine. And all of these things, you can also just use any of these other, even long strings, you can use the same kind of string methods from before, you know, dot count and stuff like that. If you wanted to search for a letter and say, like, hey, what is the index position of this thing? You could define a function that does this. Unnecessary, but you could. And so here, we're going to say, here's the string. Let's look for this letter. Okay, I'm going to start at index 0. And if the index is less than the length of the string, so until we reach the end of the string, check to see if the string at that index matches the letter that we're looking for. If so, give me the index. And that will quit the function. If not, keep going, add 1 to the index, and repeat the loop, okay? And keep going. And if you reach the end of all of that and you still haven't found it, just return a -1. So that's my find. That's the find function that I'm defined. And so I can say, hey, the letter T, that's going to be index position 7 right here. 0, 1, 2, 3, 4, 5, 6, 7. Okay. And we got dot find. So dot find already has a method. We didn't have to do my find here. We could do dot find, and it will find that. It gives us T. What's the difference between find and dot index, right? Because if I did dot index, I also get back the number 7. It says, hey, T is at index position 7. Okay. The difference between dot find and dot index is what happens if there's a character that it doesn't encounter. Dot find, if you give it something that doesn't exist in the thing, like a $, it will give you back a -1. If it can't find it, it'll say -1. That indicates it didn't exist, okay? Dot index errors out. And so depending on the behavior you want, maybe you want it to stop, right? If the thing doesn't exist in there, maybe that's a problem and you want your operation to halt. Dot index is the thing to work, okay? If you're just looking to see, maybe it's there, maybe it's not, I don't want it to crash, dot find. The in operator is this, just looks for a substring, okay? So A is A in bananas, that's true. Is nan in bananas? Yes, that's also true. What about bad, B-A-D? Nope. Okay. String comparisons. This is basically, is one before the other in the alphabet? Is capital A before the letter capital B in the alphabet? Yes. Lowercase a before lowercase b? Yes. Now the weird thing about the letters is all the capitals are before all of the lowercase. So is capital Z before lowercase a? That is true. Okay. What about the digits? The digits come before the capital letters, and you know, this is kind of like you have to treat the digits as if they were characters. So which comes before the other in the alphabet? A or AA? So A comes before AA in the alphabet, and so zero, single zero, comes before double zero in the alphabetical order, okay? Also weird though is like 1 1 and 101, okay? So you think, well, 11 is smaller than 101, so that should be true, okay? However, if you think about like the letter, if you had a word BB versus BAB, which one comes before the other? BAB comes before BB. So in this case, we're going to get a false because it's treating it as if they're alphabetical, not numbers, okay? There's no rhyme or reason. I mean, the rhyme or reason for the symbols is ASCII order. So everything's ASCII order. So here I put in all of these symbols and I say, hey, sort them. So much like a list, you could also do sorted on a string. And this is what you get, okay? Sorted will give you the string broken down into elements, all sorted into order. And so this is the order in which the symbols are arranged. It's a little like, it's totally wonky, okay? So exclamation point comes first, then pound, then $sign, and then you got parentheses up here. They come before any of the letters or numbers, but then the square brackets come here, and then the curly braces come at the end. So I don't know how it works, but it's based on the ASCII table. Okay, that's it. We'll wrap up here.